Hi guys, I want to show you how to solve derivatives using the power rule. So the power rule is in this yellow font right here. And it looks like a bunch of stuff just randomly thrown together, like it's all different shapes and sizes. It looks a little bit intimidating and messy. But all it's doing is, ignore this right here. All it's telling you is this is what you're going to get in your problem, like your questions, in that bracket, and you're going to turn it into this. That's all it's telling you to do, right? So it's pretty straightforward. It's one of, I argue it's one of the easier rules. There's like a handful of them. There's like 4 main ones. This I think is the easiest. So let me give you an example. Let's say you have x squared, right? It kind of matches what I put in the circle and the brackets. And what we're going to do is we're going to convert it into what the arrow is telling us to do. So what is it telling us to do? It's telling me to take my nth degree, right, which is my exponent, and I'm throwing it in the front. And then I'm taking that exact same nth degree in the exact same spot it is, and I'm subtracting it by 1. So it's going to look like this. It's going to look like 2 that I brought down, x, 2 minus 1. That's what it looks like. And what is my answer? It's 2x with a little 1 of an nth degree. Because 2 minus 1 is 1. My final answer is 2x. I just cleaned it up. That's all I did. That is the answer. So x squared derivative is 2x. That's how we're going to do these problems. Some of these problems are pretty straightforward, and then some of them, it requires a little bit of thinking. I have roughly 10 problems we're going to work on. So let's see. The first one is a 2. I have to find the derivative of 2. How do I do that? Well, it doesn't exactly follow the power rule. Like right away, it doesn't follow that because I don't see how I could set it up to make it look like what it's asking me to do. So why does it look different? Well, because number 2 is a constant. So a constant is a number just hanging out by itself. There's basically no alphabets touching it. There's no like X at the end or like underneath it or before it or anything. It's just naked by itself. Anytime you see a constant, which is just a number by itself, hanging out by itself, its derivative is 0. What about this one here? Y equals negative 3. I mean, I'm guessing it's a constant because it's following the rules of just not being next to anything. It's just hanging out by itself. So is this a constant? But there's a negative in front of it. So do I keep the negative? Is it negative 0? Like, what do I do? Well, even if there's a negative or not a negative, if it's categorically a constant, which means it's just a number hanging out by itself, there's no alphabets touching it, its derivative is 0. So that is also 0. Both of the first 2 problems we did is 0. What about this next one? It's a whole fraction. It's negative 1 over x. No, it's t squared. Okay, what do I do here? Because I don't remember doing a fraction in this example up here that I was given. So what do I do? Well, step 1 is to always get rid of the fraction, right? So we're going to do negative, right? Because it gave us a negative. I have to keep that negative. And my 1 over t squared is going to turn into t negative square. Anytime you have a fraction, you're going to turn that exponent, that little nth degree in the bottom, you're going to turn it into a negative number. And this is the setup. That's what it's going to look like. I haven't done any math yet. This is just the setup. I'm about to start doing the power rule math. And what is that math? I take my nth degree, I throw it in the front, and I subtract it by 1. So it looks like this. Here, let me move it up here. It looks like this. It's negative 2, right? Because I got the first negative from here. I got the second negative from that 2. So there's 2 negatives. I have the letter t, and then I have negative 2 minus 1. That's my setup to start doing my math. Well, negative 1 times negative 2, there's a little invisible 1 in here. Anytime you just see a negative, there's an invisible 1. Negative 1 times negative 2 is positive 2, We're going to keep that t as is. Negative 1 minus 1 is negative 3, right? This is the answer. And here's the thing. You see that little negative 3? You can turn that back into a fraction if you wanted. It's going to look like this. This is also the answer. Both of these are correct. Just like I turned this t square into a t negative 2, I applied the same concept in reverse. That's how it became a fraction again. What about the next problem? I have f equals negative 2x to the negative third. What do I do? It looks like they already got rid of the fraction for me. If they didn't get rid of the fraction for me, this is what it would look like. It would look like this. Or it would look like maybe like this. Right? And then I would turn it into literally this. Both of those would make me have the same exact outcome. But they already did it for us, so hooray. Okay, so I have negative 2x to the negative third. What do I do? Well, I'm going to take my nth degree, my exponent, I'm going to throw it in the front, and I'm going to subtract it by 1. So what does that look like? It's going to look like negative 2 times negative 3 x negative 3 minus 1. And what does that give me? Well, let's see. Negative 2 times negative 3 gives me a positive 6, right? Because two negatives make a positive. X negative 3 minus negative 1 gives me a negative 4. This is the final answer. And of course, you can also turn it into a fraction, right? You can do 1 over x to the 4th power. What about this next one? It kind of looks similar to the answer we could have gotten had I completed it into a fraction. I have g equals 4 over x to the 4th power. Okay, how do I do this? Well, I mean, there's a couple of ways, but let's go ahead and do one method, which is the numerator and the denominator gets separated. So the numerator is the top part, which is a 4. The denominator is the bottom part. Right? So that's my setup, but of course I got to get rid of the fraction. So I'm going to do 4 times x to the negative 4th. That's just my setup. I haven't done any math yet. Now I can go ahead and start applying the power rule, right, which is moving the nth degree to the front and subtracting it by 1. So that's going to look like this. It's positive 4, which was from the top of the fraction, negative 4, which was my nth degree, x, which was given to me, negative 4, which was given to me, minus 1, right? That is what the power rule setup looks like. Now I'm just going to solve the problem. I'm just doing just basic arithmetic. 4 times negative 4 is negative 16. X, negative 4 minus 1 is negative 5. Oops, this is the answer. Let's move on to the next one. This one's kind of tricky. I have 1/5 as my nth degree, as my exponent. Oof, that's hard. What do I do? Okay, well, let's move it over to the front, and then we'll subtract it by 1. That looks kind of hard, but let's try it. So I have 3 times 1 over 5 t 1 over 5 minus 1. That's a lot of fractions. Let's see. I have to multiply a fraction and I have to subtract. Let's see. So I have to remember some of that like arithmetic stuff, that pre-algebra stuff. I do have 2 videos on my channel, one that covers multiplying fractions and one that covers subtracting fractions, if you're interested. So when we multiply fractions, what we're going to do, the first part right here, the bigger numbers, what I'm going to do is I'm going to rewrite it. And the reason I'm rewriting it is because anytime, let me get rid of that parentheses. Anytime I'm multiplying a fraction against a whole number, I got to put an invisible 1 underneath that whole number. and then I multiply across. The top numbers get multiplied, the bottom numbers get multiplied. So I have 3 over 5. But what about this part? That's a subtraction. I can't just multiply them across. Well, you're going to find the same bottom number. That's our goal here. So I'm going to do 1 over 5 minus 1. And what is the rules when you have to do anything with a whole number against a fraction? You take the whole number and you put an invisible 1 in the bottom. Now I got to make sure the bottom parts are the same. And I have a video on this. So let's just do 5. Right? Whatever you do at the bottom, you got to do to the top. Now I'm going to subtract. I'm subtracting the bottom numbers. I'm subtracting the top numbers. The bottom stays 5. 1 minus 5 is negative 4. Right? So now I have my answers for the first part of the t and then the back part of the t. So all of this becomes 3 over 5 t with the exponent being negative 4/5. This is my answer right here. That's a lot. You know, sometimes it's straightforward, but they're going to have you do a lot of like pre-algebra stuff. What about this next one? That's a GS equals, it's a square root. Is that an S? Yeah, that's an S. It's hard to see. And I have this little tiny 5 right here. Okay, so what do? I have a square root. I don't know. I got to get rid of that square root because I can't progress forward. I have to kind of make it look like this. So what do? Well, when you have a square root, you're going to turn it into a parentheses and you're going to do 1 over 5. Here's the thing with square roots. Say you have an x, right? Let's do a basic square root of x. What does it become? It becomes parentheses x half, positive half. My nth degree, my exponent is half. What if you have 1 over square root? Now what? How do I get rid of that? It's the exact same thing. However, you're going to do negative half. You might be noticing that theme. Every time we have a fraction and then we got to take the bottom number and move it to the top to get rid of the fraction, we put a negative sign in the exponent or that little nth degree, that number dangling at the top. This is not a fraction, so ours is going to be positive. How do I know it's 1/5? There's a little invisible baby 1 right here. Baby 1 right here, right? So that's how we know. Just like up here with my examples, there's a little baby 1 right here. There's a little baby 2 right here. Sometimes they're invisible. Baby 1 right here, baby 2 right here. If they're not explicitly written, if they're not literally written down 1 and 2, it's understood it's a 1 and 2. So always know that it's always going to have a little invisible 2 here if it doesn't tell you, and there's going to be a little bit invisible 1 here if it doesn't tell you. Let's see. So I have my setup now, and I haven't done any math yet. It's just my setup. So I'm going to take this nth degree, I'm going to throw it in the front, and I'm going to subtract it by 1. Let's do the setup. 1/5 s 1/5 minus 1. Let's see. I have to do the exponents first. So I have 1 over 5 minus 1, which gives me that invisible 1, which makes it a 5 at the top and a 5 at the bottom, because I got to get the bottom numbers the same. I have a 5 in the bottom because I subtracted these together. Now I have to subtract these together. 1 minus 5 gives me negative 4. Great. So now I know that my final answer is 1 over 5s with the exponent negative 4 over 5. This is the final answer. What about the next problem? It's kind of the same, but it's kind of not. Well, what were the rules? I have to get rid of the square root. What do? I do 2, because it gave me a 2. I got to keep it. Then it's parentheses w, positive 1 over 4. It's positive because it's just a square root. Had it been 1 over square root, like a fraction, then it's a negative. but for us it's positive. And this is just the setup. I haven't done any math yet. But let's go ahead and start doing the math. I'm going to take that nth degree, I'm going to throw it in the front, and I'm going to subtract it by 1. What does that give me? It gives me 2 times 1 over 4 W 1 over 4 minus 1. Okay, well, it looks like I'm going to have to do some math again. I'm going to have to learn how to multiply fractions and subtract them. With some of this calculus stuff, we can't get away from the algebra or the pre-algebra. We can't get away from arithmetic. We got to know the basics. How do I start? Well, I have that 2 times 1 over 4. Anytime you are multiplying or adding or subtracting or even dividing a whole number against a fraction, you got to take that whole number and you got to put an invisible 1 in the bottom. I'm going to multiply across. The top numbers and the bottom numbers get multiplied. So I have 2 over 4, right? Because 2 times 1 is 2 and 1 times 4 is 4. But I can reduce this. I can make it half because 2 goes into 4 exactly 2 times. So now I know what my front number is going to be. But what about the back part? What about that small part, the exponent numbers? So I have 1 over 4 minus 1. It is a whole number against a fraction, meaning I got to put that invisible 1 in the bottom. And I got to make sure the bottom numbers are the same. When I'm multiplying, it doesn't matter what the bottom numbers are. But if I'm adding or subtracting, the bottom numbers, the denominators, have to be the same. I could basically put anything in, but I'm going to do 4 because it's the smallest number I can think of that still gives me the matching bottoms. This is called the boot and hat method, and I have videos on this. So now I'm going to subtract both of these guys at the bottom. I'm going to subtract both of these guys at the top. So the bottom is going to stay 4, because in the boot and hat method, the shoes have to be the same. Let's see. And then, what was I doing? Yeah, I was doing the top part. 1 minus 4 is going to be negative 3. Right? So that's going to be the nth degree. And the setup, because I have to use this guy and this guy, the setup for the final answer is going to be half W negative 3 over 4. This is my final answer. Let's see. What about the next one? I have GW equals 3W, and then the nth degree is 4B. Gosh, okay, I haven't had this many alphabets. This is my first time getting this many alphabets, so what do I do? Do I just move the 4 and leave the B alone? But then how do I kind of deal with the negative 1, and how do I do all that? Well, let's see. I'm going to take the whole entire thing and move it to the front. Because the whole entire thing is the exponent. I can't just pick and choose. I got to bring the whole thing down. And the whole thing has to get subtracted by 1. So what does that look like? It's going to look like 3, 4B, W, 4B minus 1. Now you're thinking, well, I'll just go ahead and subtract the 4 by 1, and then I'll multiply the 3 times 4, and then I'll have 12B, W, and then maybe I'll have 3B. Well, we won't be able to do that because these are different. All these terms are different. I have a whole number, and then I have a number with like a variable, so these are considered different. These are I can't put these together. I can't put these together. So the final answer is just going to stay as it is. This is the final answer. We can't just start joining and combining and stuff. Here are some word problems I have. Let's see. I have find the instantaneous rate of change, right? So anytime you see that, instantaneous rate of change of the function at the given value y equals x squared plus 2x minus 2, and then they give us a negative 1. Anytime you say instantaneous rate of change, all that means is find the derivative, right? Find the derivative is literally this. This is derivative stuff. All we're doing is taking every term and finding its derivative. We're just applying that power rule formula to every single one. And a term, this term, this term, and this term. So we're doing it 3 times. A term is anything between the plus and minus sign or an equal sign. So we have 3 terms. So we're going to do the power rule 3 times. Let me rewrite it. x2 plus 2x minus 2. And for me to use the power rule, I'm just going to do exactly as, oh, that 2's not really that great. Let me change it. Perfect. Cool. So all we're doing is taking that nth degree and we're moving it. Here, moving it to the front, and we're subtracting it. 2 minus 1. And then the second guy, we're doing 2 times 1. Anytime you're asked to find the derivative of just x by itself, it becomes 1. If it's just z by itself, it's 1. If it's y by itself, it's 1. If it's just the alphabet by itself, it's 1. If it's just like a number by itself, it's 0. Just a number by itself, it's 0. Just a number by itself, it's 0. So our 2x becomes 2. And if it's just a number by itself, called a constant, it's 0. Right? So let me rewrite it to make it cleaner for us. So I have y prime. That little stick right here, this little thing is called prime. It just means derivative, which is the power rule. I'm going to do 2x plus 2, right? Because 2 minus 1 is 1, so I'm going to leave that little part out. And the second one, where that x is, I'm going to leave that out too. The 0, I don't need it. Right? So now I have 2x plus 2. Now what do I do with this 1? I can't just leave it alone. Well, I'm going to actually apply it. I'm going to apply it into the x. Right? What does that give me? It gives me negative 2 plus 2. And what does that give me? It gives me 0. So that's my answer. The instantaneous rate of change for this particular function, which is a parabola, is 0. And that actually makes sense, right? If we have this right here, which is a parabola, and I had to find the rate of change, which is slope, it's going to look something like that, right? That's instantaneous rate of change. It's 0. The shape changes, right? It changed from this to this. Let's see. We're moving on to the next one. Find the equation of the tangent line of the function at the given point, right? So when you see the word tangent line, just know that we're going to be dealing with like slope and that mx plus b, or like y minus y equals m times x minus x. We're going to be dealing with those things. So when you see this, what it's asking you to do is find its derivative. And then we're going to apply these points into it. So what do I have? I'm going to rewrite it. X plus 2. With these problems, basically, we're finding the derivative, and then we're going to throw the points in that it's giving us. Both of these problems have that same concept applied. So let's go ahead and find the derivative. It's going to be 2x plus 1 and then plus 0. So let's rewrite that, which is 2x plus 1, right? I'm going to use this as m, which means I'm going to do 2 negative 1, which is x, right? Because it told me it's x. If I have 2 points, that's x and that's y. They told me what it was. X is negative 1, which they gave me. Y is 2, because it gave me that. So now I'm going to try to find m, right? So I have 2, it's negative 2 plus 1, which equals negative 1. And that's m. It just happens to look like x also. It could have just as easily been like a whole third different number, right? So that's m. Now what do? That's negative 1. And now I'm going to use the formula y minus y1 equals mx minus x1, which is going to be y. They gave me the 2 equals the negative 1 I found, x minus negative 1, right? Which is y minus 2 equals negative x plus 1, right? And I'm going to distribute this. So it gives me y minus 2 equals negative x minus 1. I'm going to isolate y by doing plus 2 plus 2. That goes away. So my final answer is going to be y equals negative x plus 1. Right? This is my final answer. The equation of the tangent line. It's asking for an equation, so we know it's going to be some long-winded thing. It's not just going to be like a single solitary number, right? So this is how you do these problems. These last two are like application problems. They're like word problems. And if you're not sure, just try to find the derivative, and then whatever little points and stuff it gives you after that semicolon, throw those in there. X, Y. It's going to be in that kind of order. So just, if you're never sure, just take the derivative, right? So there's a high likelihood you'll get some kind of points on the exam, right? I hope this helped. Okay, thanks guys. I guess I should probably tell you I do have a sticker shop if you want to check it out. Okay, thanks, bye.